Welcome back, everyone. Mr. Jens, thank you so much for being here. I see you are as excited as I am to have you all back here at IrgaCycle for our next presentation. I'm really happy to introduce to you Dr. Jens Hamprecht from BASF. And it's really a pleasure to have you here, because the last 2 days we talked a lot with people from the politics, from the different recycling companies, but to now have someone from as big a company in the industry as you, who is creating a lot of the plastics, of the products that are then processed in recycling, is really interesting. Because one of the big points all the time was that we have to think recycling from the beginning. And I think that is a lot of what you will be talking about, because that is one of the main things I think we can all do together in this, and how we can realize a really circular economy for plastics together, as your title is saying it. I'm really happy to hear about that. Afterwards, we will have a few minutes to have a look at your questions as well. So please put them down on the right or left, depending on which device you are on. You can put them in our questions box, and we will have a few minutes with Dr. Hamprecht and his colleagues to discuss them all. I'm really looking forward to this. Now, I stop taking your time away. Please go on. The stage is yours. Have fun. Thank you so much for being here.
Felix, thank you so much for having us and inviting us to give this presentation at IrgaCycle. With me today is Sebastian Heidkamp. He is a global expert when it comes to our plastic additives business, a key pillar of our circular economy that we'll address today. And he's responsible there for application business development, and will also be joined by Stefan Strege, responsible for ChemCycling, our major investment project at BASF, where he is responsible for the upstream part. The three of us would love to give you an update today on what we do as BASF to help realize a circular economy together. Together, because it's a team game, circular economy. We can and we will succeed in addressing this as value chain together with our stakeholders. Now, what's the background? We have a population now of close to 8 billion. And it's not just the number of people that is rising. Of course, it's also the standard of living. Take us in Germany. We have a carbon footprint of 8 tons per year per person, which is about double than the global average. So on the one hand, we have a rising population. On the other hand, the standard of living, and as a consequence, the resource demands are rising. And that leads us to one of the first challenges that we're having. And this challenge is the global warming. The CO2 we emit, it stays for over 100 years in the atmosphere. We, as Germany, are one of the 5 biggest emitters in those last 100 years when it comes to CO2. And we, as BASF, along with our customers and suppliers, we have, of course, contributed to this level of CO2 in the atmosphere. Jointly, we have contributed, and jointly, we need to find ways to address it and to reduce our CO2 emissions to achieve net zero. But that's just the first challenge we face as a plastics value chain. And the other one is the plastics waste in the environment. So at this moment in time, we have globally 12 million tons of plastic waste going into the environment. And when we add up all the commitments, be it the private commitments, be it the commitments of legislators, then it is not enough. The plastic waste will continue to add up in the environment. So we need to take much more ambitious measures to reduce plastic waste. And how we can achieve this through a number of pathways we will address in our call today. Now, plastic waste in the environment. We could say, does this affect us in Europe at all? because when you look at Europe, it's just 3% of our plastic waste that is unmanaged and leaking into the environment. However, even in Europe, when we ask ourselves what actually gets recycled in terms of plastic waste, it's less than 1/3, and the majority still gets either landfilled or incinerated. So in Europe also, we have a big step to go to really achieve a circular plastics economy. What are the targets that we have set as BASF? And I'd first like to discuss with you the targets that we've set for circular economy, and later on we'll walk through the targets that we've set ourselves for carbon neutrality, so for the carbon footprint. But let's start with the circular economy targets. We aim to double our sales that contribute to circular economy to 17 billion by 2030. Now, how do we target to achieve that? On the one hand, through solutions that close the loop. And today we'll talk about especially different technologies to achieve recycled content, but also renewable content contributes to that, and compostable plastics that help close the loop of the food value chain. And on the other hand, we're enhancing our portfolio of plastics that have a very high durability, that enable long lifetimes, and we work on solutions to facilitate the recycling of these solutions, as well as solutions to extend their lifetime, for instance, through additives that the unit of Sebastian is working on. And our contributions, we will structure along the value chain. So what do we do in terms of production, in use, and in end of life? And we start our journey in the production part of our plastics value chain at BASF. So our contributions there are, on the one hand, renewable feedstock. And this renewable feedstock, it can either be directly in the product, that's what we call dedicated biobased, or it can be through biomass. We'll exchange on this in more detail on the next slide. What does it mean, biomass balance, and why do we need it? In parallel to bio-based feedstock, we have recycled feedstock. For example, Stefan Strege and the team in ChemCycling, they draw on mixed plastics waste as well as tires from cars as feedstock for ChemCycling. So what's about mass balance and why do we need it? When you take the chemical industry, then one of the biggest investments you can possibly have is the cracker. The cracker that breaks down the oil, the naphtha, into fractions, into the building blocks for the chemical industry. Now, because these crackers are such gigantic investments, it is very challenging to start a new cracker running, for example, only on bio-based or running only on recycled feedstock, because the volumes in the market for now, unfortunately, are not big enough to make it economic to run a cracker just on bio-based or just on recycled feedstock. And what the mass balance approach means is the following. If we have 100 kilo of raw oil entering the cracker, and 30% of this is based on pyrolysis oil, so recycled based, then we ask a third party to monitor how we attribute these 30% to specific markets to enable those customers who pay the surcharge, the extra costs of having this recycled feedstock, to be able to communicate this as a product that originates from recycled feedstock by means of mass balance. So in a nutshell, mass balance is the means that we need as a chemical industry to make the transition. And of course, mass balance can only work if we have third parties controlling the communication and joint standardized communication guidelines on how to communicate on that. to make that transition and the actions transparent to everyone. Let's take a look at the use phase of our plastics. And in the use phase, plastics play an important role when we talk about packaging of food, for example. When we talk about our food value chain from crop production up until cooking, the food value chain is responsible for 26% of all man-made CO2 emissions. And when we look at that food that is being wasted, then producing only the food that gets wasted globally causes as much CO2 emissions as the state of India today, around about 9% of all man-made CO2 emissions. So food packaging is an important means to help food stay fresh and to contribute to having less food waste. In parallel, of course, we must redesign our value chains and make sure that the stocks are such that food waste can be reduced, not least in the households as well. When we talk about building and construction, the plastics that we produce have 3 times the benefit of saving CO2 emissions as BASF compared to the CO emissions that we require for making them. And a major reason for this is plastics such as styropor that go into construction and that enable us to achieve passive houses that are requiring almost no heating energy. When we talk about automotive, responsible, including trucks, for 9% of our global CO2 emissions, then the plastics ensure that the products are lightweight, and plastics also help drive the transition to e-vehicles. When we talk about battery housings, for example, made out of specialty plastics. When we take a look now at our plastic additive solutions, one major field of application, and this will come up on the next slide, is the use of these additives in greenhouses. And when you use such an additive in greenhouses or in any other agricultural film, it extends the lifetime of these films up to 60%. So we need to replace these greenhouse gas films or the reusable mulch films far less if they are being produced with additives such as tinuvine. Another example of how we work on solutions that extend the lifetime but also increase performance, this is Infinergy. And Infinergy is being used in well-known sport shoes and provides much better cushioning performance than the soles of sport shoes that were previously available. But additionally, because it's based on ethylene vinyl acetate, it's a material that opens up the chances to recycle the entire shoe. This enables us to produce a shoe based on one basic material and then to recycle the entire shoe. So that's an example of how we work on design for recycling. Now let's take a look at our end of life phase. And when we talk about the end of life phase, there's 3 major solutions that we're working on as BASF. On the one hand, it's solutions to empower mechanical recycling of plastics. Second, it's chemical recycling. And third, in some niche applications, but that are relevant for the food value chain and for agriculture, it's compostable plastics. Let's take a look at this overview. How do these contributions contribute together to a circular economy? And on the next slide, we will start looking at mechanical recycling. Thereafter, we dive into depolymerization, our activities there. We then address pyrolysis, and we conclude with our contributions on the left-hand side to close the loop of the food value chain. So all these are recycling approaches, and we encourage that recycling really comprises all of these technologies, because we are convinced we will need all of them to achieve ambitious recycling targets. Now, let's start with mechanical recycling. What is the challenges that we face today, the challenges that we want to help address? We have, for instance, a thermic and mechanical degradation of plastics taking place over a number of recycling steps, over a number of cycles of recycling. So we've innovated on solutions, on additives that improve the ability to recycle the product, to minimize the degradation taking place in the recycling processes. And these are the kind of solutions that we want to look into more detail today. When we look at the mechanical recycling value chain, then we have products that contribute to inspection. We'll look at these first. Then we have solutions that facilitate washing, for example, that improve the washing performance of PET bottles. And as mentioned, we have solutions in the IrgaCycle, plastic additives that improve stability and durability in our mechanical recycling. And let's now start with the inspection. Inspection traditionally is embedded in our recycling plants. So we have outstanding technology available in Europe in our recycling plants. But how about emerging markets? Myself, I'm personally engaged, for example, in Indonesia, in projects in plastic waste collection. And at this moment in time, our team on the ground does the plastic waste sorting manually. So we do a lot of training to educate the people on the ground how to distinguish polyethylene from polypropylene, how to recognize the different labels. But sometimes it's not so easy in manual sorting. And Trinamics, our subsidiary of BASF, has a solution for this. It's a manual near-infrared spectroscopy, and this can be used in the future, for instance, in emerging markets, to identify easily what is the plastic that I'm having here in my hand. So when we don't have the financial means to invest into a full-fledged recycling line, then this handheld device can tell you directly, okay, what's the plastic that this is made of, and as a result, facilitate sorting decisions. And of course, this solution is also highly applicable for our recycling operations here, whenever the economics would not be there to invest into a full-fledged recycling line with automated near-infrared spectroscopy and automated sorting of devices. So it's a step to facilitate the step towards sorting operations that are fully automated. Now I've mentioned as a next step that we also have solutions for the washing, because once materials are properly sorted, manually or automated, then the material needs to be washed. And our colleagues in the Chemetal team, they have developed special cleaning agent that enable much better cleaning performance in water, so water-based washing of PET bottles. And these solutions, such as GardoClean and the whole Gardo line, they enable savings of around about 20% in energy consumption in comparison to market benchmarks, because of the high efficiency of these products in improving the washing of PET. And that's important because apart from extrusion, the washing is the most energy intensive step in the recycling process of PET bottles. Now, when we talk about the recycling step, here we have our VALERAS portfolio. It's a portfolio of solutions that enables our customers to help achieve their sustainability targets. For instance, CO2 reduction or increasing the uptake of bio and renewable feedstock. And today we want to focus on the solutions in one pillar of this portfolio, in the IrgaCycle. And what is the IrgaCycle about? It's about enabling our customers to achieve their recycling targets. So we offer, for example, process stabilizers that are targeted for different kinds of packaging. Packaging that is extruded, packaging that is injection molded. We offer UV protection tailored to recycled polyolefins, as well as contaminant neutralizers to increase the share of materials that can be mechanically recycled and that can enter demanding applications through mechanical recycling. Now, in this IrgaCycle, we have a number of solutions available, and Sebastian will be happy to address any questions that you have on these solutions that have one emphasis on polyolefins to improve their ability to be mechanically recycled. So don't hesitate to address questions on this portfolio after the presentation. The next solution we want to address is the chemical recycling. And on the next slide, you will see that for this product line, we draw on mixed plastic waste, we draw on tires, that's for ChemCycling, but we also have technologies that we're working on to recycle mattresses. And the recycling of mattresses, this is done at BASF. We're developing a depolymerization for this, because today mattresses can't be mechanically recycled based on polyurethane into mattresses again. They can be recycled into other applications, but if we want to go back to the mattress, then we need indeed the depolymerization that brings us back to a major building block of the mattress, and this building block is called polyol. So the polyol is a major building block of the polyurethane, and we're developing technology to gain that building block back, so we can develop from that building block the polyurethane again, and can avoid that mattresses are being incinerated at the end of life. And that's also the reason why we as BASF strongly encourage EPR and take-back schemes, because how to enable a circular economy for such products if we don't get them back in the first place? For this, we need take-back systems and EPR. Now, there are product lines where, when we talk about mixed plastic waste, for example, or end-of-life tires, these product lines today at the end of life are often incinerated. They are used to fire, for instance, cement plant when they cannot be recycled. Cement is responsible for 8% of man-made CO2 emissions. And of course, the cement industry is working on solutions to reduce their emissions. And if in the future cement production is made with renewable energy to heat the process instead of waste that we burn, then what do we do with that waste? And that's one of the things that we're working on as BASF, to turn such mixed plastic waste or end-of-life tires into a feedstock for ChemCycling, for pyrolysis. And for this, we work closely with the waste management industry, for instance, with Remondis, because ultimately, the recyclers, you're the ones who know best what is the material that is best suited for chemical recycling. That's why these partnerships are so important for us with the recycling industry. When we talk about pyrolysis at a process, about 70% of the material can be used to produce the pyrolysis oil, and we need almost no external energy to run the process, because it's the minority of the feedstock that we use as energy to run the entire process. There is a side product as a result of the process. It's char that is being used, for example, in construction. And the main product that comes out, the pyrolysis oil, this is the feedstock that we use to feed into the cracker and then allocate it through mass balance to specific product lines. And on these projects, we work together with the whole value chain. So for example, together with Alba and with BMW, we take a look at plastics being used in cars. And together we think about what makes most sense. When we take this part, should it be mechanically recycled? Is it better suited for chemical recycling? Or is there, for the time being, no other way than to incinerate it and to recover energy? So together with Alba and Interzero, we're asking these questions. What makes most sense for what plastic in a car? And similarly, together with Volkswagen and the University of Clausthal and the Öko-Institute, we investigate how to optimize the sorting and how to increase the share of plastics that can either be mechanically or chemically recycled in cars. Now, when we talk about chemical recycling as one building block of our circular economy, then what are the key benefits? In a nutshell, we regard it as complementary. We're not here to substitute mechanical recycling, but together with mechanical recycling to achieve more ambitious recycling targets. A side effect of chemical recycling is that we can reduce CO2 emissions compared to incineration, but the key target for us is actually to reduce the plastic that needs to be incinerated. And for the product lines that need it, we can achieve, based on chemical recycled products, virgin quality product lines. Now, to complement the mechanical recycling and the chemical recycling technologies, we're also marketing compostable plastics for specific applications. When we talk about food waste, for example, food waste in landfills or food waste that is being incinerated is responsible for 3.5% of global CO2 emissions, or as much CO2 emissions as the entire plastics value chain. So we really need to think about solutions, how to get that food waste out of landfills where it makes methane, and how to get it out of the incineration plants where you just evaporate water. That's why we offer compostable certified bags, and we offer these for organic waste bags or for fruit and vegetable bags. There are countries such as Austria, France, Spain, or Italy, where all fruit and vegetable bags in the supermarket today are mandatory compostable. And in these markets, the products are being used as a means for organic waste collection, and they then fully compost in the composting plant. Another example is the use of mulch film, where the mulch film, if it's fully biodegradable in soil, helps avoid microplastic residues. So that's one of the solutions we offer. Either solutions through additives that make mulch film able to recycle, or to make the mulch film biodegradable and compostable. And I'd like to conclude with our targets and contributions to carbon footprint. And I've mentioned that we have as a roadmap for our way to net zero. And that is that we want to reduce our carbon footprint, not per product line, but the total emissions by 25% by 2030. And of course, in parallel, we pursue ambitious growth targets for the entire market. But despite this growth, we are fully committed to reduce our absolute CO2 emissions. this is a task we work on together with our value chain. And why is it so important to involve our value chain? When you look at the whole BASF value chain, from the raw material production, growing bio-based feedstock on soil, or taking oil out of the ground for fossil fuels feedstock, up and until the end of life of our products, our entire BASF value chain is responsible globally for 110 million tons of CO2 emissions. Now, what does it mean, 110 million tons? The total CO2 emissions of the state of Germany are about 850 million tons. So it's a significant responsibility that we have in our value chain. And when we dig deeper, where do 70% of these CO2 emissions in our value chain come from? They come from what we call scope 3. So products that we purchase, for example, from the oil industry or from the farming industry. And we have a total of 20,000 raw materials that we supply, and therefore we work very closely with our suppliers to gain transparency on their carbon footprint and to drive with them the carbon footprint down of the products that we purchase. And of course, internally, we're going through all our 45,000 products. We calculate the footprint for these and take measures to reduce the CO2 emission in-house. And one major pillar to achieve this, the reduction of CO2 emissions in-house, is that we make the transition to renewable energy. For the time being, the cracker is run at the BASF sites based on fossil resources. So we use fossil resources to heat up the cracker, to heat up the raw oil, to break it down into its fractions. But we are working on to transform this into a cracker that is powered by renewable energy, so by heat. But this causes a massive demand of renewable energy, of course. And for this year, we've announced that we will invest and source as BASF 3.5 gigawatts of offshore renewable energy. Now, what does 3.5 gigawatt mean? Is that a lot? Is that a little? The total global wind offshore capacity in 2020 has been 34 gigatons. So our BASF investment plans are around about 10% of the currently installed global offshore wind energy. And that's just a start. We are committed to invest beyond this, to make the transition towards a carbon neutral circular economy. Now to wrap up, when we look at these topics from a policy perspective, what are the frameworks that we need to make these actions take place? We are, that's the first point, convinced that we really need to look at the whole value chain. To make the right decisions in policy making, we need to look at the total life cycle of a product, find out where are the biggest CO2 emissions across the entire life cycle, and then take aggressive measures to get these emissions down. But it doesn't help us to just look at one step of the value chain, be it the production, be it the end of life. We really need to understand the full big picture of a product line. The second learning for us is we need complementary recycling technologies. There is not one technology alone that can do the job. We really need to sit together as industry, as society, and think about what are the recycling technologies that add most value for a given value chain, and then make use of these technologies to achieve together ambitious recycling rates. And in order to achieve the use of chemical recycling as one pillar, as one piece of the puzzle of a circular economy, For this, we need acceptance of the mass balance approach, where we allocate, audited by third parties, one share of a total feedstock to customers who are willing to pay the extra costs that result from using this recycled feedstock. So that's the framework that we work on as BASF, and we look forward now to your questions and comments that you have.
Thank you so much already for this wholesome presentation, to all the things you are doing, to all the projects you are on. Really interesting. Thank you for that already. Please put your questions now into the question box. The first ones are already coming in. We have a lot of time left, so I'm really looking forward to look at that. And yes, so the first one. Of course, first, thanks you for your talk as well. And then you mentioned additives in agricultural foils and how to extend their lifetime. Do you have an estimate to the share of the total market for films in agriculture which are still used without additives, so without UV blockers? I don't know if you can say something about it. It's quite specific.
I can. But Sebastian can do so much better than me.
Perfect.
Yeah, hello everyone. I hope you can hear me.
Yes.
Properly. Great. Yeah, so I think agriculture film is a specific market where, of course, most of the time some UV additives are already used because the durability is key. When you see sunlight on so-called mulch films or even glass, like big foils, that it's needed to be stabilized against UV light degradation. And I think also when you reuse, let's say, material later in the stage, you need to re-emphasize this, or let's say repurposes and restabilize it again. So I think this is the key in overall. When you ask about a specific number, I think it is very difficult to estimate. It really depends also in which region you are. You have to imagine that the weather is different in Florida, it's different in Southern Europe, and different in Asia Pacific. So it really depends also where you are. So the amount of additives in these films are depending on the region. So again, I think in overall, we'd say 70 to 80% of the overall market for, let's say, plastic film used in agriculture are already using additives. But it's important when you think about repurposing or increasing the durability, we need to think about increasing the additive rate in addition to that. So I think a specific number I cannot give you at the moment, but I think it's just to give you the perspective here. Thank you.
Thank you so much for that. And yeah, maybe can you say something about what do you think are the steps we would have to take to improve that?
Yeah, I think Jens already mentioned that it's important to look on the different steps in the value chain on one hand, but also we need to think about when we want to bring plastics back into the loop. It's important to think what was the first life of the plastic. So really to know, okay, it was used maybe in an outdoor application or it was used in agriculture film, then we can understand what the properties are of this recycled film or any kind of polymer, and we can understand then what it needs to take back, to take it back into a new life or new application. So I think this is important to understand when you think about specifically mechanical recycling of plastics and how additives can help here.
Thank you so much for that view, of course. Another question coming up is regarding especially the composition of plastics and how you are going forward with that, because we all know products made from multiple plastics are always harder to recycle than single streams. How is your strategy with that, and how easy are your materials identified in the process of recycling? Because of course this is another topic we can talk about in a minute. You're of course also researching a lot of virgin products, while of course working on a circular economy. Maybe you can give us a view on that as well.
Yeah, I think Jens, but maybe I just take a first step on that. It's a big question to think about.
Please, yeah, sure.
Like,
sorry,
right?
not
That's
to
basically looking on design for recyclability or design for recycling. And of course, we have talked, and the industry is talking about single use of material. In films, you usually have multiple layers with different materials, right? We would like to take this to a lower amount to have recyclability. And from our point of view, from the additive point of view, we are looking to integrate potentially also properties which are coming from different layers into a single polymer layer with additive solutions, for example, right? So I think it's important that from the additive side, we try to understand to let's say take out some of the layers, some of the functional layers, and bring it back into the polymer matrix with an additive, for example. So simplification, of course, is something we really look as well from the so-called design for recycling. And that's one part I can add to this. And I think maybe Jens, I'm sure you have anything in addition to say on that. Thank you.
No, I fully agree, and I'd like to add to this that yes, absolutely, we look into this question. So for instance, we've published on our website a third-party study looking into what happens if polyamide is being an element of the polyethylene recycling chain. So what happens to the tear resistance? What happens to puncture resistance of product if you have a polyethylene with a certain level of polyamide contamination? And to our surprise, we find that there is actually more compatibility than we would have assumed. And we will share the link to the study online so you can review the results. But of course, that's not the target. The target is not to have the polyamide as an element in a polyethylene value chain. To avoid this mixture happening in the first place, we're working closely with the developers of sorting technology to identify what are either pure PE fractions or what are PE fractions with a smaller share of polyamide. And this combination of having a hands-on experience of what happens with small percentages of polyamide in PE recycling, and on the other hand, improving sorting, will help us achieve a high performance mechanical recycling.
Thank you so much for those insights, of course. And to go maybe even a little further in that topic and into your stand on this, because you told us your goals and they are quite ambitious, and you have a lot of projects. Of course, you're an industry titan, of course, with a lot of capability. But still, what do you think is really the next big step, or what are the things that will make the big difference, to say it like this, that will bring us really forward toward that circular economy? What will make the next big difference, maybe in the next 5 years for us?
When you take the energy industry, 20 years ago, it was terribly inefficient to run electricity based on wind energy, so the state had to subsidize it. Today, the newest solar energy plants in Saudi Arabia and the most efficient offshore plants are clearly more cost competitive than building a new coal plant. So over a period of 20 years, the learning curve has led to lower costs for these new technologies. We will see such a learning curve for all technologies that we mentioned. I'm convinced that for mechanical recycling, there's much more we can do to improve the share of products that can be mechanical recycled, be it through improved sorting, be it through additivation. In parallel, chemical recycling isn't operating in tens of thousands volume yet, so we will see learning curves there. Basically, we're working on all of these solutions, and I think similar as in the renewable energy sector, the same way like we need wind and solar, I think we will need a combination of recycling technologies. We're investing in all now. and we think we will need all of them, Felix.
Thank you so much. Truly, that's completely true, I think. I've got another question here, pretty specific on the end-of-life tires and the oil derived from those. And it's about one thing we see in a lot of places in recycling right now, that there isn't actually enough product, enough second life product to use for all the things that are needed, and especially the oil derived from chemical recycling of used tires. This is the question: do you see a competition emerging here, especially with your ChemCycling product and the Black Cycle product from Michelin Orion? And how do you think is the oil or feedstock substitute for which should be given preference in this point?
That's a great question. That's a great question. So first of all, preference should definitely be with the tire that can be directly recycled into a tire. So that's the smallest cycle. Absolutely, let's go for that. The challenge that we will see is we will succeed over time to increase the recycled share in such tires, but it will be very challenging to go for 100%. So what do we do with the part that does not get into a tire? Do we incinerate it, or do we put it into pyrolysis for ChemCycling? We're convinced that then the better answer is to do chemical recycling of those tires. And we really need to think this globally, because tires, they are being produced in a couple of plants, but they're used really globally. So we need to get those tires back through EPR systems, through reverse logistics, to our chemical industry, to the rubber industry. And we cannot address this problem in Europe alone, because in Europe the production is beyond our own consumption. We can only solve it by resourcing it from the regions where it's been sold to. And that's why we as BASF work on pyrolysis and ChemCycling, not just in European, we really approach it globally. We look into this in all regions. This will not say, to be very clear, that we will invest in every region a ChemCycling plant, ChemCycling operations, but we really look at all regions. Where is plastic seen as a waste? Where is there no need for it? That's in our own interest, not to be in competition.
Thank you. Thank you. That's the thing in the end, isn't it? Really nice. One thing I would like to go even further on that topic, because yesterday in the morning we had a really nice panel discussion on the end of waste regulation in the EU market, and we had Peter Westman from the European Commission and a lot of industry people from the industry, especially also from the tire industry, and we had a strong discussion about whether to prioritize end-of-life tires for an end of waste policy. Do you have any points on that? Because there the big topic was always to build the market for second life tires in recycling, and how do you think will that affect your possibility to go even further with chemical recycling?
To answer this question, we really need to look at the life cycle. We should promote as policymaker the solution that offers us the lowest carbon footprint. I don't have the numbers now for tires. What is the most carbon CO2 efficient alternative? But this is what I would recommend to a policymaker, to ask a third party to do a study to find out what's making most sense in terms of total life cycle assessment, and that should be then the highest priority. For example, that's also how we handle it for food and feed crops. Here the highest priority is that crops that are being used for food production. And only the crops that are not used for food production, they should then be available for feed production. And materials, the needs of the chemical industry come third. So we need to look at the life cycles to make the right decision.
Thank you so much. Perfect. Here's another question coming in onto our topic from before, and I would like to get back to that regarding the additives, whether they would become a problem in the future, in 20, 30, 40, 50 years of time, because they could accumulate in plastic. What is your plan for that? Do you at some point stop adding additives, or what do you think will happen here?
Yeah, maybe it's a question from my side. Thank you for this question. I think it's a very important question because, of course, you need to think about how long, how many times you really can recycle a plastic. I mean, maybe we're looking partly at 50, like that 30 times, 20 times, right? At a certain time, there may be also an additional part of an additional volume of additives inside, which may has an impact on recyclability. However, we currently see that between 5 and 10 times it's already feasible with a limited low amount, and then we don't expect to have it a very high increase of additives, which make it then very difficult to recycle. So I think it is an important question to be addressed. We're currently, as I said, looking on maximum 30 to 50 times recycling and how much we actually will need to dose, but we're also looking on, let's say, new additive solutions which need less dosage, let's say, are more efficient, and which will be then also, of course, later then not available in a very high amount in the end of the day. So, but again, the industry is evolving, and we haven't had a big experience yet. The whole industry is looking at the moment for 3, 4, maybe maximum 5 times, but not 10 and 20 times. I think it's something we are for sure looking into, and how this will impact in recyclability. Thank you.
Thank you. And a further question regarding this topic is, do you have measures in place already, or projects working on that, on how to measure the recycled content in plastics? Because if we think ahead 20, 30 years, as you said, now we only have 3, 4, 5 cycles of recycling. If we have these 10, 15 cycles in part, then it could be possible to get very different quality of materials, isn't it? And yeah, we already have seen your Trinamix project, which is a very interesting way to get the content of plastic, the material, which is really is. Are there any things you got on the agenda for the topic of the recycled content?
Yeah, I'm not sure if Jens, you would like to take this, but I can also.
You go first, Sebastian.
Okay, yeah, basically I think it's important to think about the so-called traceability and how things are traced, and there are some solutions which we're looking into to trace material back into the system. But of course, depending on, I think, measuring the amount of recycled content is something very complex, knowing that the material streams can be different, right? They can be part of polyethylene, polypropylene mixes, so detecting or really the amount of recycled, it's going to be after 3, 4 times very difficult to really measure. I mean, from our side, we're looking in different technology to trace material, but it's at the moment at this level. So I think with the detection device, we have a very good way to detect the right polymers and the different polymer types. But when it comes to mixes later and how much actually contains recycled content is only able with a kind of a tracing technology, which I think we're currently working at, but this is not yet ready.
So if I may ask about that, is there anything else you can tell us about the tracing technologies you're looking at? We had different presentations on possibilities for this in the last 2 days already, especially regarding crystallized tracers, which are brought into the plastics. But I'm sure there are other possibilities And as I said, I don't know if you can say anything about it, but if you can, please tell us what it is you're thinking about it and what you think will come out on top.
So maybe one comment on this. That's a good example where we really need to think as an industry. So as BASF, we're convinced that in order to succeed on the tracer technology, we need to have one joint standard. So of course, as BASF, we can have preferences for one or the other tracer technology, but it's a topic that we very closely consult on with our associations, with our customers, because we want the one technology to be widely adopted that adds the biggest value. So I think we really need these kinds of joint discussions as you set up to come to this conclusion. What's having the biggest industry support, and that's what we should go for then.
Yeah, I think I also would like to mirror that, also given the complexity and the challenge. I mean, there are a number of technologies around in the market for a long time already, right? And we need to make sure that we have something working in the industry. And I think, again, for me, it's also from our side, it's the collaboration point here to also what we can bring from the chemical point of view to the table, and that's where we are at. So unfortunately, we don't have a solution yet, but I think there are ideas here, and happy to discuss with some industry panel or participants here in the audience afterwards.
Thank you very much, and I think that's already basically a really good conclusion for our whole presentation and discussion afterwards, because in the end this is what it's all about right now, to find these solutions together in the recycling industry with you as the producer, with the waste management companies, with the recyclers and everyone else, to just get to a point where we get that common ground and these common technologies, these common resources to get to the circular economy in the next 10, 20, 30, 40, 50 years, or whichever time frame we will need. But I think this is the end goal we are all looking for. So thanks to you for being here, for telling us all about what you are doing right now and giving us this inspirational presentation. Would you like to have some closing remarks, Jens or Sebastian, or both of you, please?
Well, I think it's the point that Sebastian mentioned out. I think the most important part for us is to really think circular economy as a team play. And we're very thankful for the questions that we're getting from you, because this also helps us think about what's the feedback we got. It's a joint process, and we thank you for offering this platform.
Absolutely, thank you very much. Also from my side, thank you so much.
Well, thank you so much for being here. Thanks to all of the participants for staying here with us, for being here with us and listening, for all the great questions. I hope we have answered most of them. A few are still open, but thank you for being here. And I would really like to have you back for our next presentation. In 15 minutes, we are starting again, and this time I will have Roger Decline from AMCS Group talking about smart city waste collection based on forecasting algorithms and IoT. So a little bit of another topic, a little more hands-on for all of you from waste management. But well, thank you, Jens. Thank you, Sebastian, for being here. Have a good day, and I would love to see you again next year. Bye-bye.
Thank you.
Thank you.
Bye.